said if two lines are parallel, then the corresponding angles are congruent. So today is the opposite. What we have is if two lines exist that are cut by a transversal and the corresponding angles are congruent, that means that they're parallel. Okay? So this one, you're given angles that are congruent, and that tells you that the lines are parallel. Okay, here we have, if two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. So these are all backwards from the ones we did yesterday. If we have two lines cut by a transversal and alternate exterior angles are congruent, then the lines are parallel. If two lines are cut by a transversal and same side interior angles are supplementary, I did it again. Sorry about that. Then the lines are parallel. Now, we have two new ones that we haven't talked about, or that are not opposite of yesterday. If we have two coplanar lines, so we have two lines in a plane, just randomly in a plane, and they are both perpendicular to a third line, then they're parallel, which is the same thing as corresponding angles, but they're specifically right angles. And then if we have a parallel line here, so like, let's say we have three lines, right? These are straight, even though they don't look at L, M, and N. If L is parallel to M, and M is parallel to N, that means that L and N are also going to be parallel. Makes sense, right? So
that's not a postulate?
These are theorems. These are reverse of yesterday's. These are new. So basically what we're saying is we can go both ways on this. If we have lines that are parallel, we can say that the angles are congruent. Or if we have angles that are congruent, we can say that the lines are parallel. It's flip-floppy. Okay? We're given that angle 2 and angle 3 are congruent. So this one and this one are the same. Okay? What do I write? Given. All right. Now I want to prove that because these are the same, that makes these lines parallel. Okay? I have a postulate that tells me if 1 and 3 are the same, then the lines are parallel. So I just need to prove that 1 and 3 are the same. Well, 2 and 3 are the same, but what do I know about 1 and 2?
Vertical?
Yeah.
Is there another word for that? Isn't that like
No, adjacent are right next to each other. So you've got vertical are across from each other, and adjacent are next to each other. Yeah. So 1 and 2 are vertical angles, so they're congruent. So that makes, because they're substituting. Okay, so angle 1 and angle 3 are congruent, so that makes M parallel to N because the corresponding angles are congruent equals parallel lines. That's how I shortcut that theorem, so you don't have to write the whole thing out. So yeah, I skipped a step. Coming back in and recording this now. 1 and 3 were corresponding. That meant 2 and 3 were congruent because of substitution, and that was what gave us the parallel lines. Sorry. So get the proof. The proof sucked, and we'll do it over tomorrow. All right. We want to say M and N are parallel, so we have to find the values that will make that true. So for that to be true, these two have to be what? Well, let's mark them. Whoops. Yeah, so they have to be supplemental because we want this situation, right? Where alternating angles are equal. So that means that I want angle 1 plus angle 2 to equal 180. Does everybody see that? So I've got angle 1 plus angle 2. So 3x and 2x is 5x. 5 and 15 is 20. I can still add that, thank goodness. Subtract 20 from both sides, and I get 5x is 160. Divide by 5, and you get x is 32. So the only way that these two lines will be parallel is if x is 32. If x is anything else, they're not parallel. Dang it. Okay. So the greens are all equals, blues are all equals. So 2 and 8, same color, so they're equal. So we're going to come over here where we can actually do this. 3x minus 4 is equal to 2x plus 1. Okay, I want the x's on the same side, so we're going to subtract the 2x from both sides. And add the 4 to both sides. So x would have to equal 5 for this to make them parallel. Thank you. Yeah, so 3 plus 6, they're the opposite colors, so they're going to equal 180. So my setup is going to be 5x plus 10 plus 120 equals 180. So I'm going to go to the next page.
5x plus 10 plus 120 equals 180.
Okay, so 10 and 120 is 130. Subtract 130 from both sides. 5x equals 50. So I'm going to divide by 5, so x will have to be 10. Make sense? Okay. 1 and 5. 1 and 5, same color?
If they on the same side, they have to equal 180.
If they're the two different colors, they're going to add up to 180. If they're the same color, they're going to equal each other. And it's always going to be that. They're always going to equal each other, or they're going to add up to 180 on these. Those are the only two options. So I've got the same color, so they're equal to each other. So this is my setup. Okay. So 5x plus 5 is equal to 4x plus 25. Subtract 4x from both sides. X plus 5 equals 25. Subtract 5 from both sides. And x equals 20. And I'll come back to this in a second. But last but not least, I have a 4 and a 6. They're the same. So they're going to equal each other. Okay. So 8x minus 17 is equal to 6x plus 3. Subtract 6x from both sides. 2x minus 17 is equal to 3. Add 17 to both sides. 2x equals 20. So what does x equal? 10.